Hello everyone. This is Mrs. Padmashri from SNS College of Engineering, Coimbatore. Today we are going to discuss about the machine learning topic, matrices for evaluating model performance, in which I am going to explain the terms of how to calculate, how to evaluate the performance of a machine learning model, which means by using the terms accuracy, precision, recall, and F1 score. So machine learning evaluation is a process that uses some metrics. As I said, like accuracy, calculating the accuracy, precision, recall, and F1 score. Using all these four metrics, which helps us to analyze the performance of a model. So what is this performance? Analyzing the performance of a model. Whether the model is trained properly or the model is going to give the accurate output or not. This can be evaluated through these terms. So we know that it is a multiple step process, like mainly used to generalize the future predictions. So evaluating a model which plays a very important role that we can judge the performance of our model, how it is working exactly, right? So how will you evaluate a model? It helps to analyze a model key weakness. So there are some matrices, or we can say the measurements like accuracy, precision, recall, and F1 score, in which we are going to evaluate the model performance. And one of the popular technique we can say is a cross validation, which is mainly used during the training process, during the training phase, and it is a model evaluation technique. So what is a confusion matrix? It's a simple table mainly used to measure how a classification model is working, how it is performing during the training process. Okay, so it compares the predictions made by the model with actual results and shows whether the particular model is correct or not. This confusion matrix helps to understand if the model makes any mistakes, whether we can get a chance to improve the performance of the model. So it breaks this confusion matrix, it breaks down the predictions into four categories. So we can say the four categories are true positives, true negative, false positive, and false negative. What is a true positive? Is actually it is the model correctly predicts the positive outcomes. It's a true positive. When I say a true negative, the model correctly predicted a negative outcome. And what is a false positive? Same, the model it incorrectly predicts a positive outcome. False negative, a model incorrectly predicting the negative outcome. So by having these probabilities of predictions, we are going to form a matrix which is called a confusion matrix, which measures, which always measures how well the classification is done during the training phase. See, this is the matrix. This is the confusion matrix, in which you can see here the predicted positive and predicted negative, and in this left side we can see actual positive and actual negative. So the column which represents true positive, false negative, false positive, true negative. This is how we are going to build a confusion matrix, which helps to calculate the key measures. Based on this matrix, we are going to create, like we are going to measure accuracy, precision, and recall. So the use of this matrices are used to mainly for evaluating the performance of machine learning model. So what is an accuracy? Is the most common metric which is used. We can say out of all the predictions we made, how many predictions were actually true? That can be measured using accuracy. What is this precision? Precision refers to the correctness of positive predictions. How many out of all prediction, how many we have correctly predicted the positive predictions? Okay, what is a recall? Recall is actually can say capturing all the relevant instances. Like for example, we can say out of all the spam email, what is the portion that the system correctly identifies or correctly predicts? That is called a recall. Okay, so example, I can say with one example. So for example, the system has 8 emails, total emails 8. Out of that, the data out of 8 emails as spam, out of a data set of 12 emails. In total 12 emails, 8 emails are identified as a spam emails. So 8 of the 8 classified as a spam, 5 are truly spam. Only 5 mails are truly spam. So how to calculate the precision? So precision is equal to correctly identified spam divided by total mails identified as spam. So how many are correctly spam? So 8 is identified as spam, but out of which 5, only 5 is correctly identified. So 5 divided by total identified as spam is 8, which is the precision value. So has a precision of system has a precision of 62.5, which means email 62.5% of email flagged as spam, where it's actually a spam mails. Now we have 12 spam emails in the data set, right? Totally 12 mails. So how the recall can be calculated? Correctly identified spam. How many correctly identified? 5 divided by actual spam mails. Total spam mails. Total actual spam mails are 12. So 5 by 12, the system has the recall value of 41.7%. And one more matrices is called F1 score, which works on the combination of both the precision and recall values. See, there is we can explain, like there is a trade-off between the precision and the recall. How to measure effectively? The formulas we have for calculating all accuracy, precision, recall, and F1. Accuracy, true positive plus true negative by true positive plus true negative plus false positive plus false negative. Precision can be calculated with the formula true positive, TP by true positive, TP plus FP, false positive. Recall, true positive by true positive plus false negative. And F1 score can be calculated using formula F1 is equal to 2 into precision into recall by divided by precision plus recall. So by applying all these values in the formulas, we can able to easily calculate what is the accuracy value, how the machine is calculating accuracy, precision, recall, and F1 score, so that we can easily measure the performance of a machine learning model, and we can easily able to improve, either we can correct it or we can able to improve the performance of machine learning through these matrices. Thank you.